Hello everyone, welcome to my channel. Today we'll be talking about garbage collection and memory management in general. Before we start talking about garbage collection or memory management, we need to first preliminarily know how do programs even work. So to start with, the preliminary step would be converting the code that we have in the compiler into machine level code, which is taken care by the compiler or the interpreter depending upon the language. And once the machine code is ready, as you can see on the right hand side, we have RAM where the memory area is located. Once the machine code is ready, it gets stored in the memory area, and memory area in turn, which is in the RAM, is divided into three subcategories. Let's assume this block is the memory area, and the three subcategories, the lowermost one would be the machine code area where our entire program gets stored, and when the machine code gets run, the instances objects that's created within the script get stored in the stack. And if you want some instances and objects to be created and available throughout the runtime of the machine code, then we store them in something called heap. To further explain the concept or the mechanism behind the memory storage areas of heap and stack, let's get further into it. So memory stack. So in order to explain memory stack, we have a simple snippet of code, C code, on the left hand side, as you could probably see, where we have written a two method. One is the default main method that gets executed normally at the start of the program, and the multi method, or the function which multiplies takes in two numbers and multiplies them and returns them. So memory stack. So let's assume this block of code on the right hand side is the memory block that we have. So when the execution starts, the main method gets stored in the lowermost level, along with when it runs the variables inside the main method such as x, y, and m, gets stored along with it. So again, when we approach to m, since m calls for the multi method, the code or the compiler searches for the multi method that's in the script, and that gets run. So when it gets run, the function multi gets stored in the memory stack as well. So we have int n1 and n2 getting stored over there, and when the compile or the execution of the multi method finishes, it returns n1 and n2. Once it returns, the memory that got allocated for the multi method gets removed, for the value that got written from multi method is stored in m. And once main method gets finished executing, the last stack memory that was for main method gets removed as well. As you could probably see, memory stack works on the principle of first in and last out. Since multi method was the last one in, it gets removed first, and main method was is the first thing that was put inside the memory stack, it gets removed last. And there's a specific kind of error that's very common if we forget to know the limitations of stack memory. To further explain this, we have a code snippet on the left hand side. It's a short recursive function. As you could see, in the main method calls for a recursive function. So on the right hand side, we again assume it to be the stack memory area. So first, our main method gets invoked and it initializes a, and fun method or the function gets invoked. As you could see, fun gets run as a is probably not, as you could see, a is not equal to 0, so it doesn't get returned, and we are incrementing a by 1 and printing it, and then invoking fun again, so stack memory gets filled, and then it checks if a is equal to 0. As we know, it's not equal to 0. In fun method gets invoked again. As you could see, our stack memory is fulfilled to its brim. So if we invoke fun again, it checks a is equal to 0. Since a never gets decremented, it never reaches 0, and it keeps adding to the stack memory, and at once when the stack memory gets filled, we get thrown an error which is known as stack overflow error, which is quite a big of a problem. We even have a website named after Stack Overflow. Next type of memory memory area we have is heap. Heap is where dynamic memory allocations takes place, and the memory that gets allocated in heap stays in the heap throughout the runtime of the script. Or if you forget to deallocate it, then probably after the script exits as well. So for the functions that help to store memory in heap that you probably could see in C are malloc. Malloc allocates memory. It takes in parameter as the type of data type that you want to store, and since it returns a void pointer, you need to type past it. Then we have realloc. Realloc is already created memory, so if you want to get in memory for a single integer, you could now allocate memory for 4 integers using realloc. Then we have calloc. Calloc is a function that creates memory continuously. For example, take a string. For example, we have the string gets stored in memory continuously. Like if you increment the address of the first character, you get the second character, and likewise for calloc, the memory is also continuous. Then we have free function, which frees the memory allocated in the heap, which for using other 3 functions. So these are the basic functions in C that deals with dynamic memory allocation. Then to further explain heap memory visually, I have written a program. This is again a very simple program. We have initialized a pointer, and when these 3 lines of code gets executed, we store 100 somewhere in the heap memory. Returns an address which is typecasted to int pointer. Since it's a pointer, Z is a pointer, so it's pointing to an object of integer type. So what we are setting in parameter for malloc is int, the size of int, so which is int, the size of int is 4 bytes, so we are asking the function to allocate as 4 bytes of memory since we want to store an integer in it. So again we are using dereferencing operator, the star and Z to store the value 100 integer into the memory that we freshly created. So once this gets run, 100 gets stored in the heap area, and then when free Z gets run, the memory that we allocated gets removed, and then again we have 2 more lines where we again allocate memory for an integer and use the dereference operator. We are storing the integer 9 in it, so once that gets run, the 9 gets stored somewhere in the heap area. So we are coming into the main topic of discussion, which is garbage collectors. Garbage collectors are nothing but algorithms that are used for collecting or gaining back memory which has been allocated to objects but are not currently used in any part of the program. The pros and cons of garbage collectors are what we're going to see in the subsequent chapters. First pro of garbage collectors is that if an object is no longer reachable, then it is eligible for garbage collection. It provides memory safety by making sure that an object cannot use for itself the memory allocated for another object. Another pro of garbage collector is the fact that garbage collection is implemented differently in different languages. Higher level languages is some sort of garbage collection built in. Lower level languages we add garbage collection through libraries. For example, in C and C++ we don't have garbage collectors built in since it's a low level programming language. For that we have something called Boehm Demus Weiser GC library, which gets included at the start of the program for automatic garbage collection. So one of the very few pros of garbage collection is the fact that it saves time for programmers. For example, it replaces the need for functions such as malloc and free, which are found in C. It also helps in preventing memory leaks. Automatic memory management can eliminate common problems such as forgetting to free an object and causing a memory leak, or attempting to access memory for an object that's already been freed. So garbage collectors in essence have a very bad side as well. The downside of garbage collection is that it has a negative impact on performance. Garbage collection has to regularly run through the program, checking object references, cleaning out memory. This takes up resources and often requires the program to pass. So this is something that I would like to touch upon as well, since we have learned Python in our previous classes. Python is a higher level language that has an automatic garbage collector built in. So that what makes Python in a more user friendly language. We don't need to allocate and deallocate memory on our own, since it takes care of it on its own. So basic garbage collection in Python is done using 2 algorithms. One is reference count and the next one is generational garbage collection algorithm. Reference count takes in account the number of references an object has within the execution of the script, and then a generational garbage collection algorithm takes care of objects that self-references to itself, so it doesn't reaches to zero. If the reference to an object gets to zero, the reference count algorithm deems it to be reclaimable, and the garbage collector reclaims the memory allocated for the object. Then if an object references it to itself, like in a cyclic recursion manner, then in that case we have to wait for generational garbage collection algorithm to step in and collect it out. And that is pretty much it. Let's see you guys in the next video.